As we come to the end of this unit, we're revisiting rates of change in rational functions. Now, first we're going to review finding the average rate of change. So for the following function, f at x equals 1 over x plus 3, we're going to find the average rate of change on the interval when x is in between n equal to -5 and -3. So to find the average rate of change, we would want to find f at -3 minus f at -5 over -3 minus -5. So on this side here, if we find f at -3, that's 1 over 3, or 0.33. And for f at -5, that would be 1 over 1, or in other words, 1. So now we have (0.33) minus 1 over 2, which gives us 0.67 over 2 negative. In other words, 0.34 negative is our average rate of change. So this time we're going to estimate the slope of the tangent for the following graph. So we have f at x equals x over x plus 3. And I want to know what is the slope of the tangent when x is equal to -5. Okay, so remember, when we're using average rate of change and instantaneous rate of change, unless specified, you can use the interval of 0.01, or you can even use 0.001. It's completely up to you. So for this one, let's use 0.001. So just make sure you specify. So we're going to let h equal 0.001. That's our small interval. So we're going to find f at a plus h minus f at a all over h. Okay, so we're going to find f at -4.999 minus f at -5 all over h, which is 0.001. So we're going to be subbing in these values into our equation. So f at -4.999 is going to equal -4.999 over -4.999 plus 3. So we get 2.500. In your calculator, if you want to know the exact value, it's 7.50375 point. Yes, 0.75. Okay, so for f at -5, we have -5 over -5 plus 3. So -5 over -2. So 2.5. So these are the two values we're going to use. So we're going to have 2.50075 minus 2.5 all over 0.001. So give you a moment to solve that. So you get 0.00075 minus 2.5 over 0.001. So we get 0.75. So the slope of the tangent at x equals -5 is 0.75. So let's try a word problem. So the snowshoe hare population in a newly created conservation area can be predicted over time by the following model. So we have P at T equals 50 plus 2,500 T squared over 25 plus T squared. So P represents the population size and T is the time in years since the opening of the conservation area. We are going to estimate the instantaneous rate of change for the hare population after 2 years. So how would we solve this question? So when we're finding the instantaneous rate of change, we're going to be finding P at 2 plus H minus P at 2 all over H. So for this one, let's say let H equal 0.01. So still a small interval, but not as small as 0.001. So first we're going to find P at 2.01. And we're going to find P at 2. So I'll give you a minute to find those. So for P at 2.01, you should get 397.8. And for P at 2, you should get 394.83. So now we're going to have 397.8 minus 394.83 all over 0.01, which gives us 2.97 over 0.01, which is equal to 297. So what would we say for a final statement? So we'd say, therefore, the hare population. So how is it changing? It's increasing because it's a positive value. So it's increasing at a rate of 297 hares per year after 2 years. Okay, now we're finding the instantaneous rate of change. So if we're finding at 3 years or at 4 years, the rate is going to be different. But it's saying at exactly 2 years, what is the current rate of either population increase or decrease? In this case, because we have a positive number, it's increasing.